Okay, last homework problem of the semester. And so we got to wrap it up using net present value, which is I think it's a lot of fun. So definitely could be a lot worse. So all right, so in problem 25-3, we have a company that's evaluating 3 capital investments, and we need to evaluate and see, hey, what is the best one? So we have maintenance equipment, ramp facilities, or a computer network. And they give us the amount to be invested, they give us the cash flows by year, and then they tell us that the desired rate of return is 20%. So, all right, so let's start by evaluating the maintenance equipment. So we're going to look at that over 3 years. Then we'll calculate our present value factor. So that's going to be the present value. Then we have our interest rate of 20%. We'll use the absolute values to lock that down. For our period, we just reference the year. We skip the payment, and we do a negative $1 for the future value. Go ahead and drag that down, give us our factors. We can enter in the net cash flows. So we have $4 million for year 1, 3.5 for year 2, and 2.5 for year 3. And then to get our present value of cash flows, we just multiply our factor times our cash flow for each year. Put our line back. Then we add up our net cash flows and subtract out our initial investment, which is going to be $8 million. Add the sum of our cash flows with our initial investment to get the net present value of a negative $789,352. So I'm going to add this up just so we can see here. So here we have an investment that we're investing $8 million into. We're going to end up getting $10 million of cash, but because we have a desired rate of return of 20%, we have a negative net present value, which means it's still profitable. We're still making $2 million if we do the investment, but it doesn't meet our rate of return of 20%. So profitable investment, but doesn't meet our goal here of 20%. So let's evaluate the ramp. So let's just go ahead and actually grab this range. We'll just copy it and paste it over. So now the only thing that we need to change is our cash flows. And so this is going to be $12 million in year 1. It's $10 million in year 2. $9 million in year 3. And since we already have our then we just need to change our investment. And so in this one, we invested $20 million. So the ramp project actually has a positive net present value of $2.1 million. So we're investing 20, we're going to get 31 back, and it exceeds our 20% threshold by $2.1 million. If the number would have came back to be 0, that would mean we earned exactly 20% on the project. All right, and so let's do it for the computer network project. So we'll just copy this over and paste it. Now we just change our net cash flows to $6 million in year 1, $5 million in year 2, and $4 million in year 3. Gives us a total of $15 million invested or returned, and our investment was $9 million, which gives us a net present value of 1.7 or so million. So by looking at this, looks like our best option by looking at it is which is the ramp. So we actually get the best return because we have the highest net present value on the ramp. The other way to do this is to use Excel's net present value function, which is just NPV. We put our rate here, just highlight our cash flow values, close parenthesis, and then subtract out our amount to be invested. Which gives us to the exact same net present value. So you can either build a table to come up with the net present value or use our net present value function. So we can actually just copy this. Whoops. And so you can do it either way. The one thing is that the book does round. So if you want to round this off to 3 digits to the book, we've done that in the prior problem. So if you want to look back at the videos for exercise 21 or exercise 14, we put round functions around here to get us to the number that will actually match the book, which, as we talked about, is a less accurate number. But the books, they're just using the table out of the book and not the formula. So yeah, so if you want to look how to round it to match the book exactly, go back and look at those videos, and those will explain it. In part 2, it asks us to calculate the present value index number. So for our index number, we just take the net value of the cash flows and divide that by the investment. Let's turn it back to positive. So since we have negative here, we'll flip it back to positive. And so essentially what that's doing is that's just looking at, hey, what's the factor that we can multiply all our cash flows by to get our multiply our initial investment by to get the net cash flows. You're not going to normally use that when you're when you're factoring in or coming up with an analysis to see what's better. You're going to use the Excel function here or set up the table. So then part 3, which proposal offers the largest amount of net present value per dollar invested. So overall, the best return is we have the ramp because it has the highest net present value. But the highest net present value index number is right here, is the computer network here, because we're actually not that far off in the net present value of the project, except we have to invest way less. I mean, this is a $20 million investment where this is a 9. So, if we're looking at total net present value, the ramp is the better deal. But total net present value per dollar is probably going to be our computer network.